Hello everyone, so I'm Chris and nice to meet you all. Okay, let's go to the talk. So when maybe a year ago, I heard a lot about AI for software development, and I have some free time to explore what does it take to build software. So there's a lot of code benchmark, but they try to build real software using AI. And so I go to the code, which is a tool that many people like. I ask them to build my e-commerce website using some framework that I know. And this is what I got. Well, it is not really what I expected, but okay. But now the question is, how do we go from here to build a real e-commerce website? What is the path forward? And by exploring that path, I think it will uncover the understanding of what does it mean to build software and what it is fundamental of software engineering. And yes, so welcome to my talk, Revisiting Fundamental of Software Engineering in the AI Era. So, how do we go from there, right? Then, okay, so the simplest way is to maybe complain, this is not e-commerce website, it doesn't even have product page. And now I explain on what the product page looks like. And then I got this, which, okay, getting much better now. But have we ever think about what are we doing in these steps? So we have first thing in our mind, e-commerce, and this doesn't work, and we getting another problem. What are we really doing here? What we're doing here is we try to break down the big software into small but solvable steps, right? So even if we go back before AI, what do we do when we have big software requirement? Client always gives like a vague and big one, like, oh, I want my new e-commerce, I want new reward system, etc. So what do? We start breaking it down, right? We start, oh, if you want the e-commerce website, then you need these pages. And for each page, then what kind of components do you have? You need API. And in the API, you might even structure that, oh, that's in the right way structure is controller, service, repo, databases, etc. So there's two fundamental steps of non-trivial software engineering. If you build big enough software, not a toy problems, then first step is that you need to turn the big problem into trivially solvable step. And once it's small enough for you to be able to solve, then you try to solve these problems. And I think you start to see the similarity, right? Because in building the code by hand and AI, right? Because you need to go through this anyway. Sometimes you may need more time to solve small problems because if you code manually, but this structure of building software still remains the same. And so I want to talk a little bit about what is the nature of coding via LLM. If we look at my previous examples, right, you might be able to start to see that AI seems to be good at small solvable problems. Maybe it's bigger than what human can do, but still, right, when I give large enough problems, then I need to break down a little bit to the AI in order to solve it. But maybe not good at turning the big problems into these steps, right? It still needs me to go into that and explain. And why is that? This is just the limitation of AI currently, or is it fundamental properties? So one thing I can say is that there is a well-known problem in the LLM, which is context loss. Essentially, it means that once you give large enough context, the performance of LLM exponentially degrade. If you look at the graph here, right, then the orange line. At some point, the context is too much. AI fail to pay attention. You have 100 pages of specification, and AI doesn't understand where they need to pay attention anymore. So the performance dropped rapidly. And it happened to every model, you can see there. So you won't get working e-commerce by just dumping 100 pages of specs into AI. That doesn't work. Okay, now LLM is getting, when we heard everyone saying that LLM is get better at coding, what does it mean? It means that it's good at solving small problems. It learns a lot from the internet, right? So if you have very small but well-defined problem, sometimes that problem can be very difficult, but LLM is very good at that. And that's what coding benchmark do, by the way. Coding benchmark never benchmark about, normally speaking, it don't benchmark how well it is good at building e-commerce, but it have more of lead code style problems where it can be very tough, but very small and limited. But then when it comes to large problems that you need to give it a lot more context, then LLM cannot solve it well. And I can say that it also the reason why we need AI coding tools on top of LLM, tools like Cursor, Code, or new technique, workflow, spec-driven, is because of these fundamental properties of LLM. It will break with the large context. Big short form doesn't really work well, right? Then if I try to say that in e-commerce, it doesn't work well, but if I break down into different questions, I have can you help product list page? Can you help product detail page? Then it starts to perform better. But also you can see that there are different ways that I can break it down, right? I can break it down in the way that page by page, I can break it down in, oh, I don't have database yet. Can you build me the database for product? I don't have API yet. Can you build API? So the breakdown can happen in a different ways, but it's still about breaking down. And I will get back to this later. And to emphasize my point, when AI coding tools like Cursor, Code, and etc. or spec-driven, essentially what it do is try to breaking down the large problems into small and context-free problems, right? There's a recommendation from Code that, oh, if you build any large thing, you should ask LLM to plan first. And what planning really do? Planning just try to create to-do list, right? It will create to-do list first, and then it will build across the board. So you can see it's all about breaking down. And when we talk about spec development, event development, it's a very overloaded term. It can mean very different things. But because there's many workflow to spec development, spec kit, hero code, have a little bit different flavors. But essentially, the common themes of spec-driven development is don't build it immediately, just build the spec first. And there are different ways to build a spec, but you can see that fundamentally speaking, it's still about breaking down the problems to the smaller steps. It's still the same in that way. And Sarah already talked about, like we can have agents of deploy, agent testing, agent of development. It's still the same principles. We want to break down the big problem into the smaller context-free problem and send it to agent of back-end engineer, send to agent of front-end, or maybe send to agent of testing. You can see that it's always about how can we break down the problem, right? Even this technique is still based on the same single principle. So the first fundamental skill for all of your software engineers is understand how can you break down the big problem into smaller context-free solvable problems. And what do I mean by context-free? Okay. So if I have a problem where I present the wrong promotion to the inappropriate promotion, the e-commerce, present inappropriate promotion to the client, right? then I can do is I can prompt in two ways. I can prompt in the way that, oh, we are building the e-commerce spec. I give the LLM 100 specs. And based on this, the user still not satisfied and complain at this. And user did click A, B, C, D, E, etc. Can you help with this? And of course, we know from the research, right? When we give so many things, so many contexts to the AI, it's break. It have the context dot problem. But if I can give just right enough context that, okay, can you write the function that you find the minimum number given array of promotion price, so I can offer that promotion price to the client, then LLM will perform really well in the right. So, anyone here heard about prompt engineering? Can you raise your hand? And anyone heard about context engineering? Okay, I want to talk about that a little bit because 1 year ago, around 1 or 2 years ago, prompt engineering used to be very big topics, right? And prompt engineering was all about how can we give more context. Oh, we should give examples. That's the one-shot prompt. We should ask LLM to think before act. That's a chain of thoughts. And we should also give the roles, right? The prompt engineering is always more about, usually, not always, usually more about how can we give more context. And at some point, we learn that give more context doesn't always a good thing. And that's why we now coming up with a new term, context engineering. And if you look at the context engineering, which I not go detail to, it's talk about it will perform, AI agent will perform better when we give just the right amount of context, not more, but not less. And that principle, that is a very strong principle when we building AI agent. In the AI agent world, they learn about that. What I'm a little bit surprised today is that I think sometimes when we think about AI, using AI for coding, we are still thinking in the prompt engineering world where we want to give more and more context about coding, about our system. But you know, from that principle, we should give just right context, amount of context, not more and not less. And that's why AI will perform very well. Now, let you see technique, right? That AI coding agent try to solve this by essentially try to ask LLM to break down these big problems. Can we rely on that? I would say to a certain degree, but not totally, for two reasons. The first one is a probabilistic accumulation. So if we have very, very big problems, right, and it breaks down to multiple sub-problems, we know that essentially LLM is non-deterministic, so it can not guarantee 100%. And assuming that every problem can be solved with 99% correct at the time, but when we chain all these sub-problems together, then probability that everything will combine together will reduce to 36%. So that's the one reason that it might not work as well as you expect. And another reason, which I think is more important, is that internal structure matters. So I think one of the misconceptions that we have, not really, but I think it's going to be more and more today, is that software, as long as it solves problem to specification, is okay. But that's okay if you are building software once and you will never change again, right? But normally we don't build software once. We might rewrite, but we still build software for the future, right? So if assuming that we need to change the software, then how you divide the system matters. So I can bring you back to my examples of e-commerce. So when I start prompting the e-commerce to build the product page, it gives me this structure where it pricing is embedded to the product. And also the stock count also embed to the product, so it can show stock count on the left, okay? But then you can see that with this structure, right, it doesn't really support product variant, so my site cannot support where I have iPhone black and iPhone white, right, because there's no product variant. Stock, there's no stock per variant, and you cannot even offer multi-price because price is embedded directly to the product, right? I cannot have the promotion system on top of this. But you can see that at the current moment, it works to the specification. It works. And well, if I try to tell AI to build scalable version, it might think and it might provide a version that have product variants and everything. But if I go that way, then there is a trade-off. What I gain from using this, having the product variant and having the stock and not embed price directly, I gain scalability, but that comes with more amount of code, right? That more comes with a little bit more response time because now it's indirect, it's not embedded in the same table, and now it's come for a little bit more resource that you need to use. So I gain some scalability, I lose some of those. Then, well, the problem can be solved in two ways, but one way have one trade-off, another way have different kind of trade-off. And even if I don't do code by myself, right, when I think about this, then even if I don't do code by hand, it still affects how we prompt. If I prompt in a simple way, then if I prompt in the top, product should also have price, the LLM will get price into the product. And if I ask it to create pricing module, it will have the more scalable pricing module. So you see that even though I don't do code manually, thinking about the internal structure can also still lead to different type of prompts. So, second fundamental skills is we need to understand, right? Because one problem can be solved in different ways. So we need to understand different trade-offs that we make when we choose what kind of solution that we use here. So regardless of using code, handcraft code, or AI-assisted code, these three steps still remain essential. Define the problem well and clear, break problem down into solvable problems, and it can be many different structures, right? In e-commerce, you can break it down in the way that price embed in the product directly or have pricing module separately, and it has different trade-off, right? And after you break down into multiple solutions, then you need to choose the solution that appropriate with appropriate trade-offs. These three steps remain regardless of handcraft code or AI-assist code. So this is what I want to revisit today. These are fundamentals of software engineering. But wait, if I look in another, not really another, but I look into more broad question, what this mean? So in the book, Fundamental of Software Architect, right, it was written that the first law of software architecture is everything is a trade-off. So when I talk about these three steps, did I try to trick you all to learn about software architecture? Maybe, possibly, but you can see, right, that on that slide, break down problem is in multiple ways, and choosing the right trade-off is kind of looks like what software architects do, isn't it? Well, at first, I really want to claim that I want you to learn about software architect, But when I look into the definition, there's a different definition that industry is still arguing. Some people say that software architecture need to have enough large scale. Some people say that, and if you are doing it small scale, it's still software design. So I'm reluctant to claim that software architecture is all you need. But anyway, what I can definitely claim is that the ability to come up with multiple solutions and choose the appropriate one is the fundamental capability for software architecture, and building small software is applied to both scale. And that's a good news because I think, I'm not sure, some of you might not be taking a role where you have exposure to big software architect stuff, right? But you can see that this applies from even your day-to-day work to the large scale work. In the small scale, you have some options like, I can solve this using array or hash map. What should I use? I can solve it using one cohesive function or divide it to 3 different functions. What should I use? Or should I have a thought in a existing class or in new class? That's both, you can see, it's all solve the same problems, different approach lead to different trade-offs. In the medium scale, there are questions like, should I use direct SQL or should I use ORM? Should I use new API in resource-based or in task-based way? Or should I embed this acceptance criteria into end-to-end test level or in unit test level? You can see every solution, two-side valid solution to the problems, but each solution comes with different trade-offs. And in the last scale where software architect do, right, where we choosing about should we go microservice or monolith, sync and sync, containerized or serverless. But everyone here have opportunity to practice this skill, okay? Not just software architect. So if I try to scale to the software architect world, and there's a lot of buzzword in this, right? Cloud native, microservice, event-driven, etc. But I can say that I can definitely build e-commerce software using any one of these. I can build it in domain-driven design, or I can build it in non-domain-driven design. I can use monolith or microservice. I can use cloud, or I cannot use cloud. Every one of these can build the software and can solve problems. But it has different trade-offs. If I choose monolith, then I get simpler infrastructure. I get stable connection between modules because it's a function call. If I choose microservice, I gain independent ability to independent release. I gain autonomy in teams. I lose some things. If I use event-driven architecture, I gain the decoupling between language, right? Domain language. I can have multiple subscribers to single events, but then I lose and not really guarantee response because now it becomes a sync communication. There's a complexity in tracing if I use request response in the different side. And if you're using LLM to build software, LLM will automatically choose one of these solutions based on their training data. Does it appropriate to your organization? I don't know. But good question to ask, right? So, in other words, I encourage you to be more skillful at software design and software architecture. And it is not really about finding just one particular solution to the problem, but it is about choosing the appropriate solution to the problem. Okay, then what now? What have we learned today? So there are 3 things that we learned, right? We learned that due to context degradation, context.problem, AI can be very helpful when to problem solving to the certain size. But then when it big, you need to break it down. And there are multiple ways to break the problem down, and each ways have different trade-offs. So ability to break down single problems that you have into multiple ways and choose the appropriate one, that's the fundamental skill. Software architect is about trade-off, and again, I want to repeat again that I do a lot of software architect to different organizations, and I can say that I used to build software in many different styles. It all works, but I need to choose the one that appropriate to each client, not just choose the microservice because microservice is the new cool things, right? Or not choose domain-driven design because it's always the good things to do. I need to choose the right one for each organization. And that is my capability. So as a software engineer, what could you do? What I encourage you to do is that so if you have problems, try breaking down into multiple ways. Don't stop at just one solution. There are many ways to solve the problems. Try breaking down into multiple ways. And now, as you have multiple options to solve the same problem, look at it, see the difference, see the trade-off. Don't just think that it's all the same because it's solve problem anyway. There are subtle differences, okay? And learn to connect the trade-off that for each solution into the wider context of organization or the problem or the software that you build. And that is the things that you can do. And in the world where initial solutions come easy, ability to choose appropriate solution really matters. I choose to talk about this topic because I see a lot of software engineers, right, that are so anxious. I see a lot of people become anxious about what is our value. Will our job still be here? And I can say that personally, I did a lot of assessment projects for multiple organizations. And when they come to me, when clients come to me, it's not like they don't have working software. They have working software that currently solve that problem. They come to me and they ask, is this solution appropriate? And this is my ability. I am not, and I know this is my value, right? I know a lot of solutions, and I can choose the right one for them, or I can decide the right one for our client. But that starts from me in my younger age. I solve single problem in multiple ways, and I learned the difference, and now I get the skills, and now this is my value now, and with this, I am pretty confident that I will not run out of the job. I'm personally confident with that. And I want to say that that can be your value too. Thank you.